So can you hear me? Yes. So first rule, you should not trust Monty's numbers. So buongiorno, that's as much Italian as I can speak. So the rest of this talk will be in English. I'm very happy to be back here in Florence. I came in 2011 for the EuroPython that was here, and there I introduced a very young project called OpenStack. And now I'm happy to be back here 7 years later, and a lot of things happened, and it's time to look into what happened and derives from interesting lessons and some tips and tricks that you can apply to your own projects and share them with a wider community. So I'll present a number of lessons. I'll present a number of tips and tricks that we learned openly developing at a massive scale. So what do I mean by openly developed? Well, by openly developed, I mean an open source project that where anyone can participate on a level playing field. Monty mentioned that a lot this morning, so I won't go into too much detail, but the idea is that you don't have a special group of developers, you don't have a main sponsor company that holds the keys to the kingdom. Everything is transparent, anyone can participate and will be considered an equal participant in the discussion. The other thing is, what do I mean by massive? Well, OpenStack grew a lot over the past 7 years. Monty gave a few numbers, I'll give different numbers to illustrate that. So the first one is the number of Git repositories under the OpenStack technical committee governance, and not necessarily all the ones that are managed by the OpenStack infrastructure team. But if you just consider OpenStack, it's roughly 800 Git repositories that are used to produce OpenStack itself and under the governance of the OpenStack technical committee. We have more than 7,000 contributors to OpenStack since 2012, when we actually started counting. And that's over the past year, more than 2,500 were still active. So it's still pretty massive amount of people being involved. It's also a very active project. So 80,000 changes merged per year over the last year. You might not be able to relate to that number because it's a bit abstract. So to give you comparison points, the Linux kernel, which is admittedly the largest and most active open source project ever, merged 71,000 commits over the past year. So OpenStack in aggregate is actually more active and larger than the Linux kernel itself. 22,000 test runs per day. That's like Monty gave a number with number of tests per hour. This is tests on a regular business day. We would average to 22,000 test runs, just testing that the proposed change to OpenStack don't break the software, and that runs on over 1,000 virtual machines that are generously donated by our infrastructure sponsors. So that's 1,000 virtual machines running in parallel to deliver that kind of output driven by Zool that we're hosting. And that adoption of OpenStack means that we have millions of CPU cores of computing power that is directly managed by OpenStack. We run a user survey where users can just report the size of their installations. And based on that survey, we have about 6 million CPU cores being driven by OpenStack. And that's just the tip of the iceberg, because there's a lot of organizations deploying OpenStack without us knowing or them reporting the size of their installation. This picture is from the Large Hadron Collider at CERN. CERN is running its computing infrastructure on top of an OpenStack installation, has 300,000 CPU cores worth of computing power there. Another very large OpenStack installation is the PayPal eBay infrastructure, which runs on more than 100,000 physical servers, which on obviously multiple data centers. It's a pretty large scale, and we are very happy to see this adoption everywhere. So yeah, overall I would say it was a wild ride. A lot of our focus during those 7 years was to just handle that growth. It was very difficult to adapt our processes and tools just to capture the level of activity that we had. So we did a lot of yak shaving was involved due to us reaching the limits of the tools we were using. So we were just like trying to fix and improve things. So we migrated from Visitor to Git. We migrated from Jenkins to Zool. And we are currently migrating from Launchpad to Storyboard, which is a task tracker that we developed internally because there aren't any good open source tools to do the kind of collaboration cross-project that we require. So yeah, now it's calmer. OpenStack is not growing that much anymore. It's pretty stable. The components are getting more stable as well. So it's really time for us to reflect back, see what happened over the past 7 years, and try to extract some hard-learned lessons and share them with the rest of the open source community. That's why I'm here. So lessons. First one, you should ignore the haters. It's an important one. I mean, in any reasonably successful project, you will always have a group of people that will just come to you and try to denigrate what you're trying to do. Sometimes it's just people that weren't there at the beginning and feel like they're missing out. So it's easier to just like be on the side and say what you're doing is stupid. Sometimes it's just professional pundits that just watch from the sidelines and like to criticize everyone else working, like this guy here. And OpenStack has been predicted dead a lot over the past 6 years. So that prediction dates back from 2012. OpenStack will not last more than 2 years. Red Hat reported a record year of revenue last year, $3 billion of revenue, and cited OpenStack as the main driver behind it. We have lots of adoption. And yet, people still continue to say, well, OpenStack is dead or will be dead. And my advice here is just don't listen to those people. Just do what you do, pursue your goals, and time will ultimately prove you're right and they're wrong. The second lesson is that, and that's the major lesson I learned, is that hype goes up and down. Hype is this excitement around your project when people just go to your conferences, press articles, describe what you're doing. You have like thousands of contributors showing up trying to contribute to your project. But it's fueled by curiosity. Like people don't really understand what the software is for, so they are curious. They want to learn more about it. So it sells, obviously, press articles that talk about your projects also sell well. But at one point, this curiosity just goes down. Like at some point, most people realize what the software can be used for and cannot be used for. And at that point, the hype goes down. At that point, you see some organizations involved, mostly vendors, realize that your project is not this magic gold mine that they can just go and extract money from and be relevant in the 21st century. They actually need a business plan around it. They actually need an idea of how they will want to use it. At that point, two things may happen. They might completely drop out of the game because they realize, oh, it's an open source project, might not be able to make that much money out of it. Or they will dramatically readjust their investment to align with that business plan that they came up with. And at that point, when hype goes down and companies start pulling off resources, you see friends that you've been working with for the past 5 years disappear because they are reassigned to something else. You have to be strong because it's like a bit of a depression point. You have to realize that at the end of the day, what ultimately matters is your users and your adoption. As long as you have users, you're good. Users are really what ultimately matters. And past that depression point, you realize that boring is good. Boring is really good. Turns out that once you remove the hype, infrastructure software like OpenStack is kind of boring. And that's good. Hype is extremely toxic. You get, like people would watch every word you say, try to extract some drama out of it, write a press article saying you're doomed. It puts a lot of pressure on developers because we like to communicate really freely. And so if anything you say can be spinned into some clickbait article and sold for like just speaking badly of your project, that creates a lot of pressure that you better you're much better without that pressure. Now that we don't have that much pressure, the developers are having saner discussions. We don't like fear that they will be spinned in a weird way. You also get rid of poisonous people. Some people are just attracted by this hype and the glory and the money. And once you're past that depression point, you realize that you're left with the people that truly believe in your project, and you get rid of all the poisonous people that were just like entitled, interested in people that just wanted their share of it. Follow-up lesson. You're not the last thing. It's something at the peak of the hype when everything is going well for you. You can be tempted to think that your solution is the end of all things. Like it will solve all the problems forever. Like it's the technology to end all technologies. And the reality is, you're not the last thing. Something else will come. Something else will steal the hype. Something else will come after you. And you need to prepare for that. If you don't build your community in a way that can sustain that drop of the hype, you're very, very fragile, because you have to be able to adapt and scale down your processes when the hype will go, because it will go at some point. One great way to stay grounded is to participate in multiple communities, because engaging with beyond your community will give you that perspective. It's very easy to also fall into the trap of thinking that your community can do everything in-house, and we've done that in OpenStack. We thought at some point that our community called OpenStack can build everything, and we don't need to rely on other things. So we encourage a lot of projects to be created within OpenStack, and that was not a good thing. And I think it would have been way better if we engaged with different communities at that point and had contributors that would contribute to multiple projects. So I said, as long as you have users, you're good. But users don't appear out of nowhere. You have to cultivate them. And it's very important to try to get your users engaged and actively participating in the feedback loop. So how do you grow a community of users that you can tap into to ask for feedback? In OpenStack, we managed to create that engaged operator community, but that was done at almost in reaction to developers, which means that now it's more difficult for us to have a good sane relationship with the two communities. If you build your operator community as a reaction against developers ignoring users, then that rift will stay for a long time and it will be difficult to fix. Another important lesson I learned is how important marketing is. I mean, as coders and engineers, we focus on building a thing up to the release point, and everything else that happens after release is discarded as useless crap, like marketing, branding, events, communications. We don't like that. But the reality is now I realize how much communication, branding, events, t-shirts were instrumental in growing OpenStack to the thing it became. There were lots of alternatives when we started. Some of them were even openly developed. But what set OpenStack apart was the quality of that downstream work. And now, reflecting back on those 7 years, I realized how much it was important to do that properly. It's easy to do if you're in a community that is owned by a single company, because then obviously the marketing department from that company will take care of it. But if you're in an open collaboration, if you're working on Python, on OpenStack, then there is no single company that will help that. And it's much more difficult to do marketing in an open, transparent manner, because marketing is based on splash announcements and stuff. So it's a bit of a struggle, but it's really worth it. As a more specific example of what we did not think too much about is like product management and branding. So we did do everything we did in OpenStack was called OpenStack and put in the same bucket. And we all blame Monty for that idea. Because because so we said, well, if this is produced by the OpenStack community, that means it's OpenStack, right? And so everything we did was branded OpenStack and put in that same bucket. Now we realize that it confused a lot of people because people are still asking what the fuck is OpenStack. And that's the most asked question ever. And there is no easy answer to that. Is it like a community of people building stuff? Is it like a product, a specific thing? And it was both, and that was very confusing. Now we're starting to take aggressive steps to fix that. And the first one is to market Zool separately from OpenStack, because it really hurt the adoption of Zool to be completely tied to OpenStack. People thought that it was only usable with OpenStack. And now we have decoupled those things, and the OpenStack community is producing two different things, and that's okay. Another important lesson, being massive does not prevent you from being fragile. It's easy to think when you have thousands of developers, just nothing can happen to you. But reality is you hinge on a very limited number of key developers doing strategic stuff. And so it's always a handful of people that will make your project work, even if you have thousands of developers. So this curve is trying to illustrate that. It's number of developers on vertical, and in horizontal, the percentage of changes that they produce. So it's a graph from the last year, 2017. So we had 2,535 developers contributing to OpenStack then. But if you look, half of the changes were actually authored by less than 100 people. 93 people authored half of the changes, and the 40-ish other contributors contributed the other 50%. So if you don't, and I mean the real reason for that is that some roles are really hard to fill. First, like companies prefer to invest in tactical changes, like a bug fix that will fix a bug that affects them, or a feature that they need for their product, or that kind of very, very narrow contribution. And what you need is people contributing strategic changes, like fixing the bug that affects everyone, or doing release management, or QA, increased test coverage. That's all what you really want for your project to be sustainable over the long run. But it's not natural for organizations to contribute that instead. The second thing is that at the peak of the hype, the developers are king, because they can just pick wherever they work and decide what they will be working on. And they tend to prefer things that are creative than maintenance work or boring work. And so there is also this tendency to have some roles that are harder to fill, like release management, QA, if you just let developers choose what to work on. And finally, some roles are just not well aligned with your constituency. You have coders, Python coders, you will find them. But technical writers or UI, UX experts that will make a nice UI, well, we didn't have that many of those. So they were always difficult to resources to fill. Next lesson. Over time, people will join your project. You have to be ready for that. An error we did really early on in OpenStack is we assumed that our principles would naturally transmit to newcomers. And that worked for a while, but at one point, we realized that the culture was not transferring anymore. And we realized we should have documented our culture a long time ago. And so we did that, but that was painful, and we should have done that earlier. We should not assume that it will naturally transfer by oral tradition. At one point, there will be a critical mass of people that are new, and those people will need pointers. The real lesson for that is that over time, people will leave. Life happens. You can't really rely on your core group of leaders, initial leaders, to stay forever. They will move. They will get run over by a bus. Something will happen to them. And at that point, if you don't have like a bench of leaders ready to step up and take their place, you're in a bad position. So you need to train people. You need to train them to realize that they will be stewards for the community rather than kings, that will have more duties than rights. It's not something, when people look at OpenStack leadership, they think, oh, those people can decide anything. Well, the reality is we don't decide anything, and in the end, signing up to do governance stuff in OpenStack is more like a set of work to do. And so we need to train them to realize that, because if they expect to be able to do anything once elected, they will be very disappointed. You also need to provide a lot of opportunities for them to step up and recognize when they do, because you need them to be ready to take your place when life happens. Getting closer to the end of the lessons, another one we encountered is how we scale development itself. In OpenStack, we split development teams across components that we produce, and that works really well. We have co-reviewers, and they are the people that can actually approve a patch. So we require that at least 2 of them approve finally, after the code review, the patch for it to be merged, and then it has to pass the tests, and that gets in the code. But if you don't want all co-reviewers to review all the changes, they have to trust each other. They have to trust each other to review this the same way. You have to trust another co-reviewer to do the same review you would do, because otherwise you feel compelled to review everything, which is not really working well. And there is a number, Dunbar number actually, around that. And that's around 16 people, 15, 16, 14 people. Trust starts to break down, and you can't really trust a group of 20 people to act the way you do. You can trust a group of 12, but not 20. And so trust cannot be scaled up. You have to scale it out. And the solution is to split code into smaller areas that you can have smaller groups be responsible for. That sounds pretty obvious, but the problem is, how do you do that once you reach that critical point? Like, you will have developers that will want to keep control over the code, and they will have like a review bottleneck because they don't want to split it up and like delegate responsibility for another part of their code. So sometimes it's difficult to fix when people don't want to let go of an area of ownership. And that's just one way that Conway's law will bite you. Who is familiar with Conway's law? So Conway's law says that organizations that design systems are constrained to produce designs that are copies of the organizational structure. Basically, the way you organize your project will bleed into technically how things can be done. And in OpenStack, organizing development around those project teams, which was very efficient in getting them to get to a certain level of functionality. Now that we need them to be more stable across once deployed together, like cross-project work to make sure that projects work well together, then you have this organizational structure that goes in the way. Doing cross-project work in OpenStack is painful, and that's because we organized work in around development teams centered on components. So it's difficult to do cross-project work. It's difficult to track cross-project work. It's difficult to reward cross-project work because everything is tailored for contributors that contribute to a single silo project, and that's one way of that Conway's law actually bited us in the past. We need to be aware of that. Okay, end of lessons. Now I want to switch to axioms. Axioms are rules that seem to apply to every of those massive openly developed projects. We've seen a number of them. Kubernetes is the other recent massively openly developed project that we see, and the same errors and the same problems are appearing there. So there seem to be a number of things that just happen every time, and that's a few things I want to insist on. First, you have to have the 4 opens for it to be a truly an open collaboration. So Monty touched on the 4 opens this morning: open source, open design, open community, and open development. If you only do some of those opens, then you will not have a truly open collaboration, and people will be tempted to fork your project and do it the right way. So if you accept contributions in a very, very level playing field, but you still only give the ability to choose which features will be developed to a close group of developers, at some point it will break down. Like, people will realize they're just free labor for fixing bugs, and the interesting stuff is done by that group of people. Or if you don't provide opportunities to step up, but you have like nominated positions in your governance body, that means you can't really become a leader in that community, and at some point people will leave because it's not very interesting. So you have to do those 4 opens to have a really open collaboration. This one is the dirty secret of open collaboration. It has a cost. Doing things the way we do has a cost. You will go slower. Like, there's just no way you can go as fast as you would go with a very dedicated startup going to try to reach a level of features in your project. You will go slower, a lot slower, because you need to have this consensus across the participants. You need to convince more people. You need to go through code review. You have to accept that things go a lot slower, but you will go farther. There is this African proverb that says, if you want to go fast, go alone. If you want to go far, go together. And that applies extremely well to open collaboration. You will go slower, but you will go a lot farther because everyone will be behind you. Another dirty secret of open collaboration is that it will inevitably lead to scope creep. It's just difficult to say no. Someone comes with a feature and they have a use case. It's an open collaboration. How do you say, well, your use case sucks and my use case is just better? And so it takes a lot of leadership to refuse features in the name of a scope that you define really early on. And so you end up with a project with lots of plugins, lots of components, lots of options, things that are beyond your scope. It's usually ends up very confusing. You have to fight that really early on. You have to define barriers, things you won't go a precise scope that you should not overrun. You have to put barriers in place to resist the scope creep because it will happen. It happened to us. It happened to Kubernetes as well. So how do you say no and say this is completely beyond the scope because we said the scope was this? Good or slow? As engineers, we like to count things. We like to measure performance, progress. We like to continuously improve in our numbers. As humans, we like to compete with each other. And that means we do derive metrics from the development activity because it's so well defined that you can spin up those websites and say, this is the top leading company that contributes the most patches, or I have contributed more patches than you did, or this is the people that contribute to this project. So you end up with a website that compares people, and then people start using that as a target. And Goodhart's law says that a metric ceases to be a good metric when it becomes a target. If the metric becomes a target, the metric basically is useless because people will game it. People will be incentivized with the wrong behavior. So we started counting code reviews in OpenStack to try to encourage people to do code reviews. And now we have plenty of people just like +1, +1, every patch. And then they have like thousands of reviews, obviously, but they did not review anything. And that's the bad incentive that you get. It's a difficult one to fix because if you don't provide the site, someone else will. We did not provide the site for OpenStack. Someone else built it and ended up giving some weird rewards to their employees if they ended up at the top of the chart. They just won sports cars. It's crazy. Anyway, do you end up with those very, very weird things? So how do you fix that? I don't have like a good advice. I think it's another axiom that seems to happen every time. I think you should provide the site, make sure that it like provides the right incentives rather than the wrong ones, but I don't have a solution on that. Last axiom, face-to-face time is necessary. As much as we like to think of us as a very global and distributed community that can be very efficient just using online tools, reality is there are a number of things that you need face-to-face time to fix, like building trust, building shared understandings, solving hard problems, agreeing on priorities. Those things really benefit from having a high bandwidth interaction with people. And we realize in OpenStack that it's really useful for us to get together at least every 6 months. because that's about the moment in time when you start hating the people you don't see. Like at one point in development, you realize you hate that person. You only interact with them when on IRC, on mailing list. You keep on arguing with them, and it's time for you to meet that person again, have a few beers, discuss other things, and that's only happening in a face-to-face relationship. So yeah, you should plan to have face-to-face time to fix it. Okay, this close to the end, I want to give a few best practices that you might want to apply to your project to start it on a good foundation. The first one is you should document a clear set of principles. Open source projects are ultimately social beasts. People are joining a community, they're not necessarily joining a project. So describing a clear set of principles from day zero will help set expectations as to what the community is about, what it truly believes in. Something we did, like in retrospect in OpenStack, was a very useful exercise. Like just say that we run our infrastructure only on open source tooling. It's something we did from day zero, but not something we wrote. And I think it's really useful to set those expectations, document them properly. Will help you build that common culture that will spread across your contributors. In terms of project governance, you should have just enough governance, 2 rules to follow. Only put governance structures where you need to have final decisions made. If you don't need a final decision to be made, you probably don't need to have a governance structure at that level. But you should also add enough structures to represent properly the people that will elect those people. Like you don't want to have multiple subgroups under a single governance body, because then the largest subgroup wins and the smaller subgroups are ignored. So you have to balance those 2 rules to try to get just enough governance to clearly map to the constituency you have, but also don't have useless governance bodies. In OpenStack, we have the technical committee at the top, which is used to escalate issues in every project team, and that works well. Like we don't have that many things to discuss, more project additions, project removals, global policy principles, that kind of stuff, but not that much technical decisions to be made. A lot of projects just go with the BGFL model, which I call non-governance. It's really the default thing, and it's very brittle. It works well as long as the person is around. The moment that person disappears, it's really shady. I've been in a number of open source projects like Gen2 and others that did not survive well their BDFL disappearance. So you should put in place a governance before it's too late, and not rely on cargo-culted non-governance, which is the BDFL model. If you want to be truly global, you need to build your processes around inclusive community processes. In OpenStack, when we started, we did weekly IRC meetings, and those meetings were happening in Europe/US compatible time zones. And we did not realize that it was like breaking people from China from contributing. Turns out that the convenient time for us is 4 a.m. their time, which is not convenient for them. And turns out that China has a lot of people, so it's silly to just exclude them. They already have a hard time with language barriers and tooling barriers. If you add the time zone to that, it's just like they won't be involved. So you should try to rely on less on weekly meetings, more into asynchronous discussions, mailing lists, and in-person meetings to solve the difficult questions, because weekly meetings, synchronous weekly meetings, will always screw up someone around the globe, because obviously it's a sphere, and it's always night somewhere. You should adopt code reviews. Monty mentioned that earlier. We should force everyone to go through them. Nobody's code should just get approved without code reviews. Even if you have someone that never makes a mistake. We have Doug Ellman in OpenStack, which wrote a number of books on Python, and he's always right, and his code is always perfect. But I like to review his code, because then I learn new things, new libraries, and so it's was a great learning opportunity for people to do code reviews, and in the general scenario, it avoids creating a special group of developers, committers, separate from the normal people that you ask to contribute to your project. Code gating, Monty went through that at length this morning. You can't merge code unless it passes tests. From day zero and up, we did that. If it's not, we said if it's not tested, it's broken, and it's not just like a gimmick. With OpenStack, when we did not test it, it clearly became broken really fast because of the complexity of the interactions between the components. So it's always good to do code gating. You get a lot of side benefits, like having always usable branches, a test-first culture. All those things are very interesting. It just takes a bit of guts to set in place so that people don't hate you because they can't really push whatever they want. But I think it was very, very interesting in OpenStack. Time-based releases, that's more my field. In open collaboration, you will not be able to predict when features will land. You will not be able to predict what people will be working on. So if you try to do feature-based releasing, which is waiting for a specific feature to land to do the release, or promise that something will be in the next release, then you will do a very bad job at it. And you should embrace the benefits of time-based release instead. Time-based release, you know when the release will be made. You don't really know what will be in there. But then you can plan a vacation around it. You can plan events around it. You can plan, like the marketing people will already know when the thing will land, so they can prepare stuff. It puts everyone in a way better position and avoids just, like, you should embrace the benefits of time-based releases rather than do a really bad job at feature-based releasing, basically. Automation everywhere, plenty of benefits, will save you a lot of time, obviously. In OpenStack, we automate more than we should, I think. But that's because when you automate a boring task, nobody has to do it anymore. So even if you take like 10 times more time to automate the thing, it's still worth it because it's interesting to do automation work. It's not interesting to do boring work. So we did that a lot in OpenStack. And last advice before we conclude this talk and go to quick Q&A, final best practice, you should eat your own dog food. Like, you should use the software you build. And beyond that, you should also live by the principles you preach. I truly believe that open source software is a better way to build software. And so I only use open source software because otherwise it's just like, it's not my laptop. It's Simone's laptop. And I'm only using open source software because I believe it's better. And so you should really eat your own dog food. It's really difficult to convince others if you're not convinced yourself. So my final advice to you is use open source software. And thank you for listening to me.
Thank you very much. So we have time for 2 quick questions, and then we can move on. And yes, that's my laptop, though.
Well, my open source laptop did not work.
Yeah. Questions? None? Okay.
Well, you can find me if you want to ask me things.
1. Yeah.
Oh.
I don't know how much you are into the Kubernetes development process, but which are the most 2 similar things in the development process or community process, and which are the 2 most different things between OpenStack and Kubernetes?
I don't know. So the most similar thing, I think, is their difficulty to fill critical roles. They're also like very much in hype right now, but we've been having discussions directly with key Kubernetes community members around the common problems we have. That presentation actually derived from that. And what's the most striking is that they all say, well, we have so much trouble getting people to work on this or that. And from the outside, it looks like, oh, this project is perfectly healthy. But in reality, it's even, their curve must be even more pronounced than ours. They're also really, really struggling to get people to contribute the useful things. they have plenty of people contributing the wrong thing. So that would be the most striking parallel. The most different thing is how they split development. They did not go with a component-oriented thing. They have like two completely different structures for organizing the work and reviewing, code reviewing. So they have they use a maintainer's file, a bit like the Linux kernel, to spread out code reviews. And they use a SIG system, special interest groups, to slice the team's work. And that's like a two-dimensional thing, while we have only a one-dimensional thing. And their stuff makes it easier to scale out the trust in the development model than what we did. So I think it's a good change that they did here.
Okay.
Good.
Thank you very much.
Thanks.